So, okay, can we start now?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
So
Yes,
hopefully
ma'am.
now we have got about 67
Yes, ma'am.
people, and I have been told that some places multiple people are multiple participants are sitting at certain places, right? So let me introduce myself. I'm not sure how many of you all know me, but I am. My name is Kameshwari. I'm a metallurgist B, and I'm posted at MDI Pashan now, and I have been allotted with a syllabus wherein I'll be taking the observation, that is the non-instrumental observations, that is cloud, visibility and present weather, along with the complete coding of the synop coding and the inland coding. Inland synop coding have got two parts, the coastal coding and the synop, the inland coding, and also the ship observation. Along with that, the autographic charts, and how do we do the autographic charts tabulation and data archival and data scrutiny kind of things. Okay, and then there's one more topic which I have been allotted, that is the synoptic metallurgy में thunderstorms and its complete formation and dissipation and its effects. Along with that, again in climatology, it's a pre-monsoon season. So these are the topics that have been allotted to me for your batch. So I will be trying to complete uh, and certain periods. Maybe this week I'll try to complete the observation part, and because I'll take observation along with the cloud and this one together. Why? Because I don't want to take first one is the explanation and then second is coding. So I request everybody to have the code books in your on the table. Why? Because we will go through the code book and also the synop simultaneously, and then we will and I'll explain the cloud and visibility and present weather, because present weather is a complete coding part. So present weather may we have around 99 weather codes, so the codes have to be coded in a particular place with why it is being done so, and the criteria that you what you use to do the coding. So both the, and I do not know how many of y'all are working in airports and how many of y'all are posted at the surface observations. Now you have been inducted something in 2023. So now it's already been 2 years time. So I think 90% of y'all must be in the stage of where you're presenting or you're doing the surface observations. Am I true or not? How many of y'all are posted at observatories and airports? Can I have any figures?
I posted MO Purnia.
MO. So that means you are posted MO Purnia, so you know already the surface observation, right? So, so like that, how many of y'all have already know things?
Repeat, ma'am, please.
How many of you people are already into taking observations?
Four
Sir,
people.
ma'am, since I have joined, I am taking synoptic observations and
Okay.
messaging, forwarding it to RMC.
RMC.
It's been in
Last
one
2
and a half,
years. 1.5
1.5
years.
years.
So Karthik Yadav ji, आपका भी क्या है? And Rahul Mandal?
Currently working in Data Machilipatnam and also work at Surface Observatory.
Surface observatory. So you people may many of you. Rahul Mandal?
I am working at Emo Holdia.
MO Holdia means acha, Met observation. So you people have been already taking the Met observation. So 90% of you are aware of the fact that you know what is the A86 ka symbols. Just Mr. Jitendra Singh,
Yes, ma'am. I am working in
Jitesh.
AMS and MO Lengpui.
So AMS may ho, to then you know the current observations, right?
Yes, ma'am.
Maybe you
Current
don't
weather.
know, you know the current observation, but you do not know the surface observation. Okay. So
Surface observation also because I am also in MO Lengpui. Na?
acha, acha. So both you have been taking the surface and the current observation.
Yes.
So I can take it for granted that 90% of you people know what actually you're doing. But but as a part of the syllabus, I am supposed to be teaching you the procedures, the official procedures of how to record the observation, and in that way my part is clouds. So let's have an interactive session, because मुझे ना इतना I get bored if ever I am the one who's talking and you people are not telling me anything. So now, while if ever before we start the class, if you people can tell me what are your maybe one by one today, as it's an introductory class, can you all tell me where you find the difficulty in taking the observations? Anybody, what is that thing that you face the problem while you take the observation? Yeah, Mr. Aman Kumar, can you?
Good afternoon, ma'am. I am Aman Kumar from MC Srinagar.
MC Srinagar, okay.
Yes, ma'am, the hardest part I find while taking the observation is the amount of cloud.
Oh,
Actually.
amount of cloud, okay.
Yes, like madam, it is very clear to understand the octas, but it gets really hard to understand the layers, like what is at the lowest level layer, at the middle layer, and at the highest layer.
Okay.
And what to do when the sky is obscured by the lower level clouds, such as, let's say that there are like 6 octa cumulus clouds.
Yeah.
And I am certain that there is some alto cumulus as well at the middle layer.
Correct.
But how to know what data to give when we cannot actually see the middle level layer clouds?
Right. That one question, that is I'll answer. The next person, somebody has raised his hand. The second person who raised a hand right now, Dimapur. Yes. From MO Dimapur, please.
Yes. Hello, ma'am.
Yes.
Difficult part is determining the height of cloud. Like
height of cloud. Okay. That I will
we
teach.
can't differentiate like what height is the low cloud and at what height is the middle cloud.
Right.
It is very difficult to assign the height.
Okay, that I will tell. Okay. Next, Mr. Hemendra Singh Kushwaha.
Yes, ma'am.
Oh.
Yes, ma'am. I am Hemendra Singh from MO and AMS Kolhapur.
अच्छा कोल्हापुर में है.
Both offices are here.
Okay.
Yes, ma'am. So the more difficult part that I find during observation is that the intensity of rain, that is it is a high density, or it is medium, or it is low. So intensity of rain.
So you want to understand the intensity of rainfall, how the rainfall is there, and how do you determine whether it is rain or drizzle or it is shower or something like that. Okay, so that comes into present weather. That comes into the present weather coding, and where I will explain the entire rain part, and what is the definitions of rain, and how the rain gauge has been established, and what are the principles behind, and how do we determine whether it is a rain or a drizzle or it is a shower, and under which circumstances it comes in. And if ever you have to, especially the cloud part ke liye, see, if you are not able to determine yourself, then how do you look into the radars and also can establish what is the type of cloud. With the satellite picture and radar picture also helps you to understand and this one. There are two parts, like, we have to do is an estimation of a cloud. Okay, and when Miss Anushika Mishra.
Yes.
Yes.
Ma'am. My name is Rashmi Kumari from AMS Gaya. During the rainy season, it's difficult to distinguish between the clouds. Which type of clouds is it?
So season wise, so you want to know
cumulonimbus cloud, stratus cloud, and SC cloud. Means which type of cloud I can give during the rainy season.
Right. So you want to know what types of clouds are available during each particular season. So dominating, that also I will teach. Okay, because you see, you people have been already working in last 2 years in a particular stations and have been doing the work. That's why only I want to understand what type of issues you see, because I will be doing the entire syllabus of the clouds, visibility, and present weather along with the coding. So that I will completely tell. So what happens is, if I know what exact problems you are facing, accordingly I will limit my lecture till that place only, so that you understand what you already know. I need not repeat it, because you all are not no more a a school students, you all are engineering background people, and with maybe the BSc and MSc with physics and all, so you can catch up things much faster. So it is not that, like a classroom, I don't want to make you sit and learn line by line. But then when I'm giving you, I'll be sharing my PPTs also with you all. And that is why I just wanted to know. So now what I understand from all the thing. Yeah, Mr. Aman.
Ma'am, I am from RMC Guwahati.
Yeah.
From the date I have joined, I didn't work in observational network, ma'am. I worked in miscellaneous branch and worked on GEM portal only. Okay. So I request you to, ma'am, please start with the very beginning.
I will do this from very beginning. I'll go through every very beginning, but I'll teach everything line by line. I'll teach. Okay, don't worry.
Okay.
But emphasis,
thank you, ma'am.
Emphasis what I will try to give is on the cloud part. Okay, how do you do the cloud part and how do you do the recording part? And I will also tell you the websites where you should go and try to check how the observation is. Mr. Aman is unmuting himself.
Yes, ma'am. Thank you, ma'am.
Yeah, definitely.
Hello, ma'am.
I am Akanksha Mishra from MO Ongul. Then I find difficulty to determine types of cloud during night time.
Night time, yes, I'll tell you that.
And during rain time also, because it is predetermined that it is raining, then you should go to and AS2. But I can't see the clouds. So that is the problem.
Yes, that's what. See, so 90% of you all have the issue is with the cloud determination, cloud height, type of season, and in which type of season, which type of clouds are generally forming, and what is the situation, and how do you report it from the octa level and estimation. Okay. Second thing, what I also find is the present weather. How do you find the intensity of rain and what type of present weather you have to code and how do you do it? Third is that entire synop, because some people might have not done the synop at all. So I will try to tell you people how to go through the synop, what is the meaning of each line. Okay. And those who have never seen a synop, you can ask me questions and I will reply. Okay. So that what happens is 60%, 70% of the people already know. So they will understand. And those who don't know, please ask questions. Unless you people don't ask me questions, we take it for granted that you know. Yes. Yeah, please.
I facing a difficulty in cloud, ma'am, summer season.
Cloud during?
In summer season, ma'am.
Summer seasons, okay.
Good afternoon, ma'am.
Yeah, Mr. Siddharth.
Yes, ma'am. I am in MC Bhubaneswar and I am posted in communication unit. So, ma'am, from the beginning of my tenure, I have never seen observation and never taken observation.
You have not taken observation. Communication means what were you doing?
No, ma'am, no.
Communication means what are you doing?
Means part-time observations will come and we will make synops here. But ma'am, I have never gone to observatories and never take.
So see, part-time observation. You see, now you are taking a part-time observation. Observations come to you. So that means a part-time observatory gives you a pressure reading. He gives you a temperature, that is dry bulb temperature, dew point temperature. Then he gives you maximum and minimum temperature, and you are coding and RH, and you are coding it, right?
Yes, ma'am. But
coding is called a synop. See, coding is called a synop. There are two parts. One, you go to the observatory and take the observation. Okay. Then after taking the observation, you come up and you do what we do is that we do the as far as pressure reading is concerned, the station level pressure is converted into the mean sea level pressure, and then we put it into code. So that is AXX remains the same. But it is that you are not taking the observation, somebody is taking the observation and you are coding it, right? So I will be teaching the complete code, don't worry. Okay, but then, see, so then one day you have to go and take the observation also.
Definitely,
okay.
Yes, ma'am.
Now I'll give an assignment to everybody that you go to the observatory, take an observation and submit it to me as a assignment. Okay? So based on that, I'll give the internal marks, right? And now Mr. Ashutosh Kumar.
Yes, good afternoon, ma'am.
Good afternoon.
Ma'am, I am posted at MCI Jol. I am facing problem, ma'am, in taking the height of the base of the cloud and identifying the nature of the clouds, ma'am, during rain season.
Yeah. That's what that is a common problem to everybody. First of all, is the height of the base of the cloud, types of clouds, seasonic clouds. Which season, what type of dominating clouds are there, and then assessing the octa. And if ever there is the low cloud is 6 octa, then how do you say estimate the middle layer and upper level? Okay,
yes,
so this all I will be taking it in details. There is no problem, and that is the part of the syllabus, so I'm supposed to do it. So this is what you people are facing also, because see, the earlier batches, the people had not had so much of experience. They were just 6 months, 8 months, and 1 year of work. But now that you people have been working for 2 years, so I thought I should take the background, who is posted where, and anybody other than that. I can see 79 others, maybe it's about a 150 class, and I expect that all the people are there. See, I have completed 30 years of service in IMD, and observations are the major and very important part of IMD's requirement, and this is the backbone also. I'm just giving an overview today. If you think that you are very happy to give estimation from your mobile phones, then you are incorrect. Why? Because mobile phone sensors and actual observatory kind of a structure that we are having has a little bit of difference. See, for example, if you are taking a temperature, the temperature which is the instrument that we use is a thermometer. Thermometer, what is the element that is there, or the sensor is a mercury. So if the mercury thermometer is put on a body, it gives you a body temperature. If I can hold it in a room, it gives me the room temperature. So why we require an observatory? I can hold the thermometer in my room and say ki my room ka temperature is so and so. Why are we making such a huge big drama and melodrama of having an observatory, go to the observatory, take the observation, come and code it, and all this? Doesn't it sound like a melodrama? Even when you're sitting in a car and you're driving your car, the car tells what is the outside temperature. Right? So why should we need that? Can anybody tell me, why do we need an observatory and this melodrama?
Ma'am, I can try.
Yeah, please try. See, even if it's wrong, see, I am not a scientist or an officer. Okay. I have service experience. So because of just service experience, I know a little more than you. That's all. Nothing beyond. Okay. So you people don't. And I have also last time I was in a batch of FTC, and I have also given a lot of wrong answers. So okay. It's fine. When you are wrong, correct yourself.
Actually, the Stevenson scales in which the thermometer kept, that is put in a certain height, like 4 feet from the ground. Actually, the sun rays are actually heating up the ground, and ground then radiate it to the atmosphere or the air. So the air gets hots up, and the temperature actually rising from ground level to upper level. So as we goes high, so the temperature is dropping. So we actually calculate the air temperature. That's why the Stevenson scale have those gap in which the air can circulate freely and doesn't gets hots up as the hot air is stuck in between those. So actually we are taking those temperature of freely moving atmosphere for that. But our mobiles or our digital skills are not adequate to do that. So actually I have seen, or I have experienced that in the time of observation, maximum time the mobile temperature are going 2 or 3 degrees upper than the observation I take in the Stevenson scale.
Right. So the thing is that Stevenson scale is made up of a material called as wood. Wood is a bad conductor for the solar radiation. So what happens is that when the air, we are trying to take the air temperature, and we are not trying to take the temperature of what the outside or the atmosphere there it is. So as he said that the solar radiation, for solar radiation, atmosphere is completely transparent, and therefore the entire solar radiation is absorbed by the Earth's surface and then re-radiates in the form of a long wave radiation. So it's a short wave radiation and long wave. So in the long wave radiation, what happens is there is a conduction that's happening between the surface of Earth and the first layer. So we are not trying to take that. That is why the height has been given. And there the eddies or the kind of circulation, the small eddies which have been developing, that also have to be nullified. So to reduce the bias of the temperature and temperature to be more accurate of that particular area or that particular place, this Stephenson screen has been developed. And Stephenson was the scientist who has invented, or he formed this the screen. And this screen will be always facing north south and not east west. Why? Because there's a east west, whenever you're opening the Stephenson screen, then the solar radiation will directly fall on the mercury, and mercury being one of the elements, it will actually there'll be a variation. Therefore, the Stephenson screen is always north-south facing. Okay, and therefore we take the temperature of the dry air temperature and we supply water for a wet bulb temperature, and then the difference of it we calculate the dew point and the relative humidity. So these are the temperature part and then it also has a maximum thermometer and a minimum thermometer. So this is a temperature part what we are trying to do. So but the temperature part will be taken up by somebody else, not by me. So I've just given a preview of the temperature. But then I will be telling you how to code the temperature in the surface coding. Okay, so this is what I just wanted to start with. So but then coding and taking the observations in the right way is required. Why? Because your surface observations are ingested in the NWP, and when they are ingested in the NWP, if the NWPs have to work with more accuracy and give more accurate output with the for us to do the forecasting, then the observation quality of the observation should be more accurate. If your quality of observation is not right, then we are also having the AWS and ARG data, we have the radar data, we are having the satellite data, surface data, we have the RSRW data and PV data. So all this, and also the current weather observation. When all these observations get into a particular system, and then it is doing the calculating of the synoptic scale or in the mesoscale for understanding the climatology, or we are getting the thunderstorms and for nowcasting and all. Unless these observations are not accurate, you cannot have a proper quality check, because NWP models will reject 90% of the data saying on the quality of the instrument. Therefore, it is a responsibility of the person who is there in the observatory to check the instrument and instrument quality, because it now you, for example, if at your home you are having a refrigerator, it suddenly stops working. Do you wait for somebody to come from the neighborhood and put up and then take a replacement or put a complaint or things like that, or you yourself will do it? You yourself will do it, na? So similarly, so the person who is there in the seat and who is working there and your station in charge is responsible for communicating the non-working instruments to their respective MCs and get it replaced. So they cannot say that I am not doing it or it is not my thing, I wrote a letter. No, writing a letter and pursuing it until the replacements are not done is also a part of the duty. Okay, so we cannot say, when we say we want certain rights, we also have certain responsibilities. So our responsibility also we have to look after very well. Why? Because your wrong observations will go into the NWP with the wrong calculations, and hence and then everywhere there is a bias. See, the thermometers will have some kind of error, then some parallax error will be there. So every error, addition of every error, it just multiplies. So therefore the basic errors shouldn't happen as far as possible. So that's why double check should be done. When you're reporting a synop, you also check in the AMSs what is the nearby stations also doing it, whether your observation, because generally the temperatures and pressures do not fall and rise erratically across the same district. Okay, so after submitting it in AMSs, you people please check what you have given और the nearby airports में क्या आया है, and airport instruments and whether surface instruments are really going hand in hand. See, suppose the airport and the surface observatory are say within the same locality, so there can't be much variation, right? So आपका touchdown point पे whatever temperature is shown and the observatory meter temperature, so there should be a little bit correlation. It cannot have that, you know, touchdown point is above 2 degrees below and yours is 2 degrees above. So, and also the pressure values. So pressure values ka your calculations and the QNH and QFE ka, there should be a correlation. It cannot happen that, you know, that is something else and you are reporting something else. So there has to be a proper correlation, because when all this data is ingested and your same observation at same locality and same lat long, you can't give different observations, then it's absolutely incorrect. That means in a very careless work. And careless work is not a good habit. May I just put it in the word, if you are having some problem with the department, we are not getting promotion, that doesn't mean we do careless work. Careless work is absolutely not acceptable. Why? Because if you have some issue, you have to deal with the department in a different methodology. But because I have not got promotion, I have not got this, I have not got my transfer, I have not got my something else, and then that's why मैं क्यों यहाँ जाके काम करूँ, ये concepts जो है वो गलत है. और अगर ऐसा कोई senior आपसे बोलता है तो वो उसने पूरी जिंदगी जो है गलत काम किया है. काम में कभी भी चोरी मत कीजिए, because you will not be caught, nobody will catch you, but then you are a sinner. The person who is caught is a thief. The person who is not caught is not a thief. So आज थोड़ा सा जनरल मॉरल लेक्चर ही मैं दे रही हूँ कि आप पकड़े नहीं गए, आपका कोई मैं घर पे से भी दे दूँ तो चल जाता है, तो क्यों मैं इस तरह से काम करूँ? So but that you are cheating your own self. And when a person cheats his own self, the punishments are something the same soul will give you, because we are finally central government employees and we are working for a purpose. And our purpose is the smallest possible agriculturalist जिसका आधा एकड़ land है, and for him even 100 rupees matter a lot. So we are answerable to such kind of poor people who are dependent on our forecast, so that they can actually invest right amount of money with minimum possible investment, can make a living. Okay, so that is why this is a service department wherein every small stakeholder is our user. तो आप इस तरह से ध्यान रखिए कि when you give the observations, when you are doing your work, the person with half an acre land is our user, a truck driver is our user, aviation में the aviation companies and the aircrafts or the people who are sitting over there are our users. So we have multiple, the fishermen, जिसका फिशरमैन का जो है, फिशरमैन होता है जो भाई दिन में 100 रुपया 200 रुपया कमाता है, that fisherman is also is our user. So we are liable and answerable to all such people. So it is not that a high class very rich people take our data, but these poor people are dependent on us, and therefore we have to be sincere in our work. Why? Because yes, Mr. Abhishek Gupta, please.
मैम आपने बोला कि एक लोकेलिटी में जो है वेदर का काफी ज्यादा चेंज नहीं होता है, लेकिन मेरा स्टेशन जो है कोल्हापुर स्टेशन से काफी नजदीक है, 30 किलोमीटर अवे है. हाँ. तो कभी कभी मैं देखता हूँ कि वहां पर इंटेंसिटी ऑफ रेन इधर क्या बोलते नहीं होता, कभी कभी मिनिमम टेम्परेचर का, हाँ, कभी कभी मिनिमम टेम्परेचर का 2 डिग्री 3 डिग्री का डिफरेंस आता है. ऐसा क्यों? ऐसा मैं बताती हूँ. देखो आपने पूछ रहा है कि रेंज जो है आपका 30 किलोमीटर है. ओके, जो रेंज है वो थंडर एक्टिविटी का जो रेंज है वो आपका 1 किलोमीटर से 10 किलोमीटर का रेडियस है, वो मीसो स्केल सिस्टम है. ठीक है, तो अगर आप पूना जैसे शहर में भी देखोगे तो अगर पूना में अगर तो साउथ पूना में बारिश नहीं होगा. बैंगलोर देखिए, अब एक साइड वेस्ट बेंगलोर में बारिश हो रही है तो ईस्ट बैंगलोर में बारिश नहीं होगा, क्योंकि ये 1 से 10 किलोमीटर का रेडियस वाला है. ठीक है, ये वाला है दैट इज कॉल्ड थंडरस्टॉर्म रेन. दूसरा टेम्परेचर, मिनिमम टेम्परेचर हो जाता है अर्ली मॉर्निंग में. हमारा मिनिमम टेम्परेचर फर्क क्यों पड़ता है? क्योंकि वेजिटेशन की वजह से. सपोज अगर आपका यहाँ पे एरिया जो है बहुत ज्यादा खुला है एंड वहां पे बहुत ज्यादा पेड़ है, तो फिर आपका टेम्परेचर, आपका जो लोकेलिटी का टेम्परेचर है वो 1-2 डिग्री कम रहेगा. ओके, फॉर एग्जाम्पल अभी मैं बताऊं, मैंने ज्यादा से बहुत सारा साल तो मैंने बैंगलोर में काम किया, तो मुझे बैंगलोर का जो वो
एरिया है वो ज्यादा रहता है. अभी सिटी टेम्परेचर विल बी 2 degrees above because of the pollution factor and because of the concretization. उसकी वजह से 1-2 डिग्री ऊपर रहता है. जबकि आप IISc और या हम लोग हमारा वहाँ पे जो एग्रीकल्चर यूनिवर्सिटी GKV के वहाँ 2 डिग्री कम रहता है. IISc में बहुत पेड़ पौधे हैं. इट इज अ डेंस काइंड ऑफ फॉरेस्ट एंड दिस वन. अभी पाषाण में भी, अभी पूना में हमारा पाषाण का टेम्परेचर जो है 1 डिग्री कम रहता है, जबकि शिवाजी नगर जो 5 किलोमीटर दूर है वहाँ 1-2 डिग्री ज्यादा होता है. ये टेम्परेचर वेरिएशन जो है आपका 5 किलोमीटर, इट इज बिकॉज ऑफ द अर्बनाइजेशन एंड ऑल्सो बिकॉज ऑफ द वेजिटेशन. ठीक है, ये फर्क होना पर ज्यादा फर्क नहीं होता है ना. सी आई कांट से कि पाषाण में मैंने 15 डिग्री का रिकॉर्ड किया है और शिवाजी नगर में 20 डिग्री रिकॉर्ड हुआ. हाँ, 15 डिग्री इधर रिकॉर्ड हो तो वो 16 या 17 डिग्री रिकॉर्ड हो सकते हैं. और प्रेशर वेरिएशन, आपका प्रेशर कैसे वेरी होगा? टेम्परेचर का तो बिकॉज ऑफ वेजिटेशन एंड अदर फैक्टर्स की वजह से हो सकता है, बट प्रेशर कैसे वेरी होगा? प्रेशर वेरिएशन के लिए तो आपको वो तो सिनोप्टिक स्केल है ना. ठीक है, तो प्रेशर वेरिएशन इज नॉट पॉसिबल कि पाषाण का स्टेशन लेवल प्रेशर एंड शिवाजी नगर का, विच इज अबाउट 5 kilometers away. So pressure variation will not be much. Okay, so pressure is one of the major factors which will create the localized phenomena, weather phenomena. So इसमें तो बारिश जो है इसके 2-3 criteria of rainfalls are there. One is with respect to the cumulonimbus cloud जो कि localized है, which 1 kilometer to 10 kilometers is the radius. तो तभी है प्री मानसून पोस्ट मानसून में आपको इस तरह का फीचर दिखाई देता है. मानसून पीरियड में इट विल बी See, cloud burst का मतलब क्या होता है? What is the definition of a cloud burst? How much of rainfall per hour if we receive is called as a cloud burst. उसको क्या है कि yes, now these days what is happening is that even if 1 centimeter and 2 centimeter of rainfall, the urban areas are getting flooded. So the media calls it as a cloud burst. ओके, अब 2 सेंटीमीटर रेनफॉल का डेफिनेशन जो है, हम लोगों के पास हमारा रेनफॉल के डेफिनेशन है लाइट रेन, मॉडरेट रेन, हेवी रेन, वेरी हेवी रेन. सो लाइट रेन का मतलब होता है फ्रॉम 0.1 mm to 3 centimeters is what we call 2.5 centimeters तक का जो हम राउंड ऑफ करते हैं, इट्स कॉल्ड एज अ light rain. Then 3 centimeters to 7 centimeters is a moderate rain. 7 centimeters to 13 centimeters is heavy rain. So 13 centimeters and above is very heavy rain, and 24 centimeters and above per day, that is during a synoptic day, that is 8:30 to 8:30. Then above 25 centimeters is extremely heavy rainfall. So these are the definitions of the meteorological thing. But these days, even with 1 centimeter rainfall or 2 centimeters of rainfall, the urban areas are getting flooded. So what we are doing, that's why we are giving impact based forecast. एंड इम्पैक्ट बेस्ड फोरकास्ट जो होता है वो बोलता है भाई अर्बन फ्लडिंग. क्यों अर्बन फ्लडिंग हो रहा है भाई 1 सेंटीमीटर 2 सेंटीमीटर में? बिकॉज देयर रेन ड्रेनेज सिस्टम जो है वो इतना गंदा है, इट्स ऑल ब्लॉक, कि भाई आपका 1 सेंटीमीटर का रेनफॉल पे पूरा वहां पे फ्लड हो रहा है. because you are not given any space for the water to flow. Water is a natural characteristic of the nature and it flows from higher level to the lower level. अब low level में सब जगह पे आपने अगर बिल्डिंग बांध दी हो और उसको जाने का रास्ता नहीं दिया तो वो जाके क्या करेगा, बिल्डिंग के सामने पूरा का पूरा accumulate हो जाएगा. तो उसे क्या कहोगे, कि फ्लड कहोगे या इट्स अ अनथॉटफुल urban development?
It happened due to bad drainage system.
Bad drainage system and unthoughtful urban development is a reason for flooding, and because of that traffic gets jammed up. Why? Because it's totally waterlogged. अब वाटर क्लॉग होने के बाद में आपको पता नहीं कि वहां नीचे खड्डा है क्या है, तो डेफिनेटली द स्पीड ऑफ द व्हीकल विल बी रिड्यूसिंग. सो दिस इज एन इफेक्ट ऑफ ए unorganized urban development and unclean rain drainage systems. So ये जो है corporation का problem है, but because now we are forecasters and we are within this one, that's why in the recent years an impact based forecast करके वो शुरू किया गया है, which is there in our websites, and we are also giving nowcasting if you are there in the med centers for every 3 hours कि भाई हमारा what we try to say कि 3 centimeters, and when we say nowcasting, it has to have minimum 3 centimeters of rainfall in an hour's time. अगर वो है तो ही हम नौकास्ट दे सकते हैं. क्लाउड देखते ही हम नौकास्ट नहीं देना चाहिए, देन इट्स कॉल्ड अ फॉल्स अलार्म. आप फॉल्स अलार्म दे रहे हो, तो अभी आप हर समय फॉल्स अलार्म देते जाएंगे तो फिर आपको कोई पूछेगा भी नहीं. यू आर सपोज टू गिव द राइट काइंड ऑफ अ डायग्नोसिस ना. सी वी आर समथिंग लाइक द डॉक्टर्स ऑफ द एटमॉस्फेयर. सो व्हेन वी आर टेकिंग द ऑब्जर्वेशन, दैट the people who are taking observations are technicians. For example, अगर आपका हार्ट में प्रॉब्लम है, डॉक्टर ने बोला कि आपको ECG, technician will give a ECG ना. But if he doesn't put the those electrodes at the right places, then your ECG will be wrong. And based on that ECG, you will be given the medicines, right? So similarly, if our observations are wrong, then the kind of forecast will be wrong. So we are kind of atmospheric physicians and the technicians and things like that, and we do take the observation. Based on the observation, we do the analysis, and based on the analysis, we go to the we use multiple tools. That is, the NWP is one tool, radars are one tool, satellites are one tool, and based on all these things, cumulative data, we try to give a specific area specific, district specific, Hubli specific, village specific forecast and user specific forecast, so that the people in India get the benefit. So we are one of that kind of people who try to help the economy. For example, अब आप किसी एक फार्मर का 800 रुपया बचाते हो from you have given a forecast that tomorrow it's going to rain, and then उसका हार्वेस्टिंग पीरियड है, तो उसे पता है कि भाई अगर आज हार्वेस्ट नहीं किया तो कल से बारिश हो जाएगा तो उसका क्रॉप खराब हो जाएगा. So he will try to do it one day before, okay, so that he can save his money. And if he say okay कल light rain है, तो फिर वो क्या करेगा, परसों के दिन उसका अपना बुलाएगा. If suppose he calls the laborers and the work doesn't happen, he has to pay double the labor charges. So in all the ways, so what we try to do is, IMD ka main reason is why we are operational in nature is because we try to help the nation to have an economic balance. So we try to help the economy of the country as a back-end advisors. So therefore, we are operational in nature. So we try to help the operations of each user. Aviation, we give the forecast so that they can do the maximum, they can use the minimum possible fuel, then maximum they can increase their load. Okay, so they can take the maximum load and with minimum fuel, so that is the time, and then they use such kind of heights to fly and cruise so that they can save the fuel. In the aircraft, the fuel is very, very costly. We try to save the economy of the agriculture. We try to save the economy of the horticultures. We try to save the economy of the animal husbandry. For example, ये देखो poultry है, fisheries है, इनके लिए थोड़ा सा temperature variation, the entire poultry जो है उसको infection हो जाता है. So then they take the advanced measures so that they even one chicken gets infected, the entire farm is infected, right? तो इसके लिए फिर उसका तो पूरा का पूरा investment तो has gone waste ना. So that is why we try to do all these things. And you also, I would like to tell you कि the temperature, the variation in temperatures gives a lot of effect of the mental patients. The patients who are there in the mental hospitals, they have a direct effect of the temperature and pressure. So the doctors, and they also take this kind of, and NEMANS in Bangalore takes the observation on a daily basis, just because with the help of that temperature and pressure, they change the dosage to the mental patients who all are there in the asylums. So this is a way that So many users are there. So we should feel that we are working in one of the departments where we serve the nation in a very, 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 very required way and in a very subtle way and as a backbone. So it is not that it is something number 1 to 9. It is not number 1. Every number has a value. And so please be very careful while doing the coding and while taking the observations. Okay. So for today, I think I should stop. And if anybody wants to ask me something, Mr. Rahul Kumar, yes, you can. Amit Kumar, you can ask me. Yeah. पहले राहुल कुमार जी बोल लीजिए, फिर बाद में अमित कुमार बोल देंगे. Yes,
जी मैं एमसी आइजोल से बोल रहा हूँ.
एमसी आइजोल या. हाँ
मैम, कभी-कभी ऐसा होता है कि हमारे स्टेशन से नीचे लो क्लाउड लेवल का लेवल हो
जाता है. वो भी मैं बताऊंगी क्योंकि क्या हो जाता है.
At that time we can consider it as a fog, a smoke or a low cloud.
No, it will be cloud. I'll tell you how to do that, because cloud, the height base of the cloud below the station, this happens only for the hill stations, which are at the higher height. So वो भी I'll be explaining it.
और कभी-कभी QFE प्रेशर डिफरेंस में 0 होता है प्रीवियस डेटा से, तो उस समय क्या उसका डिफरेंस के लिए 0 के लिए क्या?
0 का मतलब ऐसा है कि प्रेशर जो है चेंज हुआ ही नहीं है ना, कल से आज तक का वो प्रेशर का इज द सेम थिंग. सो बिकॉज़
हां, तो 5.8 का कोड जाएगा या 5.9 का कोड जाएगा, यही डिफरेंस.
5.8 जाएगा बिकॉज़ 0 है ना.
जी ओके.
जब भी 0 है तो 5.8 जाएगा, -0.1 है 5.9 जाएगा.
हां ओके, थैंक यू मैम.
ओके. और दूसरे अमित कुमार जी.
Good afternoon. I am from PBO Gadag.
Oh, Gadag से. Very good.
Yes, ma'am. मैम, ये थंडर स्टॉर्म जब आता है तो क्लाउड में सीबी जो हम देते हैं ओनली 1 octa क्यों फिक्स करते हैं?
वो मैं that I'll explain you why 1 octa for CB. That I'll explain you while giving you the cloud का thing and also the synop. Because उसका एक reason है कि CB का जो cloud है, मैंने as I told you, it is only maximum 1 kilometer, 10 kilometers of the radius. So आपका जो octa है, how much of is when you're dividing into how many parts? We are dividing into 4 parts. When we are dividing into 4 parts, कितना CV होगा? Okay, so that is why it has been given only 1 octa, not more than 1 octa, because वो छोटे-छोटे cells होते हैं. So that I will be telling you in the synop also, and while teaching the thunderstorms also, I will be telling you both the times. Okay. Yeah. And Miss Met Purnia. आपका वहां पे हैंड है. मेट पूर्णिया से कौन लोग हैं?
Yes ma'am, I am Rahul.
हाँ राहुल, yes please बोलिए.
Ma'am, my other question is regarding visibility, ma'am.
Visibility, yes.
Especially in winter season, I face difficulties to representing visibility.
I will be teaching you visibility on all aspects, because visibility जो है हम लोग horizontal visibility लेते हैं, and horizontal visibility में when it is coming with fog का उसका कौन सा कोड आ जाता है and what is the meters that we have to consider, वो भी मैं आपको visibility का कोड के साथ में बताऊंगी. वो present weather में भी आता है.
If ma'am sky is invisible and there is no fog at the surface level station, then what will I?
आपको sky is not visible and fog is not there, ऐसा कैसा हो सकता है? See, you tell me. You are standing at a station, okay? आपका जो sky का जो height है, that is vertical visibility, ठीक है? When the cloud, what is fog? Fog is nothing but a cloud that is at the surface level. तो जब सरफेस लेवल पे आपको फॉग है तो आपको क्लाउड स्काई तो दिखाई नहीं देगा, और अगर स्काई दिखाई दे रहा है तो आपका फॉग नहीं है, वो मिस्ट होगा या हेज होगा. हाँ, तो कोई बात नहीं. देखो कैसा है, दिस इज द वे यू हैव टू थिंक. व्हेन यू आर थिंकिंग एंड यू आर लर्निंग, देन क्या हो जाता है कि देन इट इज एक्चुअली लॉजिकल आंसर्स. सो व्हेन यू कम विद अ लॉजिकल आंसर आप कभी भूलोगे भी नहीं. Okay, see, it is a vertical, horizontal visibility and vertical visibility, because atmosphere is 3-dimensional, right? So हम जब horizontal visibility की बात करते हैं, so you are standing at the station and you are looking at the horizon. And when you say vertical visibility, that is the cloud base. So cloud base is nothing but a vertical visibility, and horizontal visibility is what? That is the visibility, what we try to say. Okay, so that is a different phenomena, and fog comes in, because cloud base is at 0, so it is fog. And therefore you can't see the sky. Sky is obscure. But if ever you don't have fog, then your visibility is low. That time what it is like, it is either mist or it is the another phenomena called as a haze. So you can see the vertical visibility and there is a cloud also available. Okay. Yeah. Mr. Ashutosh.
Yes, ma'am.
Yes, please.
मैम विजिबिलिटी अगर डिफरेंट डायरेक्शन में अलग अलग हो तो उसके लिए क्या करेंगे मैम?
हाँ, विजिबिलिटी जब अलग अलग होगी तो हम जो मिनिमम विजिबिलिटी है वही रिपोर्ट करेंगे, जो डायरेक्शन में मिनिमम है. एंड एविएशन में भी हम जो मिनिमम विजिबिलिटी होती है वही देते हैं.
ओके, थैंक यू मैम.
अच्छा, मिस्टर शाह.
Hello, ma'am. I am from FMO Asansol under RMC Kolkata.
Okay.
So my office doesn't report individual cloud, so I don't know how to report.
Why? Because there is the one criteria. Suppose PB station. Listen, when there is a PB station, okay, or it is an aviation station, we report individual clouds. Only a Met observatory, then we don't report the individual clouds. But I will teach you how to identify the individual clouds. So that is a criteria. Okay. Mr. Aman Kumar.
And ma'am, how to I find it difficult to find the movement of cloud.
That also I'll teach you. Direction ko kaise dekhna hai, that we have it there. I will be teaching you that also.
Okay, ma'am.
Yeah, Mr. Aman Kumar.
Yes, madam, you just said that fog is a cloud that forms at the surface level.
Correct.
So, ma'am, fog does not have any shape in it, so it makes it a stratus cloud, right?
No, see, it is not a stratus. It is not a stratus cloud. Fog is a low level. See, it's actually a radiation fog or it's an advection fog. Fog ka matlab hota hai there's a sudden cooling and there is a kind of moisture available over there, because of which it solidifies and then your visibility is being obscured. Okay, so it is not a stratus cloud. It is not a stratus cloud. Stratus cloud is a different cloud. That's why I'll be taking the clouds ka total, all levels and layers. Stratus cloud is always a rainy cloud. Matlab it has a rain bearing cloud which happens only and only just before the dissipation of a CB or during the monsoon period when there is a AS completely. So the altostratus hote samay mein aapko niche jo hai stratus aata hai and stratus is moving. So they are the rain bearing clouds and they dissipate. The drizzle jab aata hai to stratus clouds mein aata hai. So fog is not a stratus cloud. It is actually the condensation of water at the surface level due to radiation, because it's a cool winter season mein aapke paas temperatures are very low and there is a water vapor at the surface. So that is why we are having the radiation fog or an advection fog. That is there's a warmer surface and a cool air has come. So there is a difference between the surface is warmer than the air that is in, that the conduction process happens and there the fog happens. That's what advection fog. Sometimes when on the say water bodies ke upar warmer air goes in, so already water body is cool and there's a difference between the two types of air masses. It is a difference in the air masses. So there we have the fog. Okay, so that is what it is. And when there is a temperature induction or when there is a temperature, the day mein jaisa solar radiation heating shuru ho jata hai ya wind hota hai, so this fog clears up. It doesn't become stratus. So it is at the surface level. Okay, so all this also I'll be taking.
Yeah, so madam, a fog can be accurately thought of as simply as a condensation.
Yes.
Not much of as a cloud.
No, but what we call it as a surface level cloud means, because why is a surface level cloud? Why? Because you can't see anything, na? It covers the whole place.
Yes,
it's a surface level. Okay. But it is not stratus, huh? It is not stratus. Stratus will have a small height. And it's a rain bearing cloud. This is not rain bearing. Fog is not rain bearing. Okay. Yeah, Mr. Rahul Kumar. Rahul Kumar?
Yeah, I have done that. I have asked.
Yeah, you have asked. Okay, fine. So I think we can stop the class for today, and from tomorrow onwards, my actual explanation and all will start. Is there something Mr. Shailendra Kumar also has put up a hand?
Yes, madam. Shailendra Kumar from Kodaikanal. मेरा एक छोटा डाउट था कि जैसे हायर मैक्सिमम या लोअर मिनिमम होता है तो उनको किस पीरियड में करते हैं और उनको सिनॉप में इंक्लूड करना होता है
हायर मैक्सिमम एंड लोअर मिनिमम को करना होता है. मैं आपको वो कोड बता दूंगी. मैं उस पे दैट इज वन पार्ट ऑफ द सिलेबस.
ब्रेक हो जाता है तो उसको फिर कैसे करते हैं?
क्या कहते हैं?
जब मिनिमम ब्रेक हो जाती है मैम,
हाँ
तब उसको सही कैसे करते हैं?
हाँ, तो वो भी मैं बताऊंगी, वो इंस्ट्रूमेंट मेंटेनेंस में आता है। यस मिस्टर जितेंद्र, बट दिस वन मिस्टर जितेंद्र, हेलो। जितेंद्र जी, आप कुछ पूछना चाहते हैं? There is a hand that has been given. So I think so. Can we end the class today for here, and we'll start the regular classes from tomorrow onwards. Maybe by the weekend, I think I'll be in a position to complete all the pehla part of observational system, and then I'll ask all of you all to take the observation from your respective. Hello. Yes, Mr. Jitendra.
Yeah, namaste, ma'am. I'm from MO Gwalior.
Okay.
Ma'am, mist basically depend more on humidity or visibility. Mist.
देखो कैसा है कि ह्यूमिडिटी एंड विजिबिलिटी आर टू पैरामीटर्स। ह्यूमिडिटी की वजह से विजिबिलिटी आपका बदल जाएगा ना। जी देखो कैसा है कि मेट पैरामीटर्स जो है इंटरट्वाइंड है। फॉर एग्जांपल, इफ यू आर हैविंग अ हाई प्रेशर, सो योर ऑल अदर पैरामीटर्स विल चेंज अकॉर्डिंग टू द हाई प्रेशर एंड अ लो प्रेशर। ये हाई प्रेशर और लो प्रेशर होता क्यों है? कोई पता है कि हाई प्रेशर और लो प्रेशर होता क्यों है? सरफेस पे हाई प्रेशर और लो प्रेशर क्यों होता है? बिकॉज ऑफ रेडिएशन।
हाँ मैम, वो टेम्परेचर डिफरेंस के वजह से।
हाँ, तो इट इज बिकॉज ऑफ डिफरेंशियल हीटिंग। ओके, बिकॉज ऑफ अ डिफरेंशियल हीटिंग ऑफ लैंड एंड ओशन, there is a temperature difference, and when there is a temperature difference, then the pressure changes as per the sea. Then we have the sea breeze and the land breeze. So it's all because of the solar radiation. What we are having a differential heating between the land and the ocean at the same time. So land heats faster than the sea. So when land is heating up, then what is happening? Kina, our pressure keep temperature difference at different, that is again different things. See, temperature difference at different levels, it is a vertical distribution what you're talking, but surface distribution at the surface level, at the mean sea level, there is a difference between the temperature heating. See, same time the solar radiation is coming onto the land as well as onto the sea, or to the water bodies. So water takes time to heat up, whereas land gets heated up very much faster. So there is a difference. When there is a difference, then high pressure and low pressure will keep changing as per the season and where availability of the sun, and in which latitude and longitude your place is there, and also the topography. So all these factors are important in the temperature variation. And when there's a temperature variation, there is a pressure variation. And when there's a pressure variation, then the wind is a transporter. So wind transports the kind of temperature from one place to another place. So who is transporting? The wind. That is why wind direction and wind speed is important. And when you require all these things, then your visibility and everything comes into the picture, right? And that is why the condensation is happening. There's a water cycle coming up, and so you have a cloud forming. So all these are the interdependent variables, and that's why we call them as met variables. And therefore we have, anabatic, katabatic winds are all further. I mean, they are going to go to something for something called as a core subjects. First of all, what we are trying to understand is what are the instruments and how do you record the instruments, say the temperature and the met parameters. After you do that, you are trying to record it in a particular synoptic condition. Why? Because unless you don't have a kind of a code, you can't write down everything and send. So the code is decoded at the AMSs. After decoding, you do the symbolic representation over charts, and when we are doing a symbolic representation over charts, then we draw the isobars, because the weather is a kind of a connection between one place to another place, and it is global. So it is a global effect. Something is happening in US, something is happening in UK, something is happening in maybe the Arabian, the Arabic countries. So it will have an effect on India, and something is happening over India, it will have an effect on the eastern or the western things based on the wind direction and wind speed, the southern and the northern hemispheres. So we have to understand the globe as such, the latitudes and longitudes, then the topography, the hilly areas, the coast, what we call as the Western Ghats, the Eastern Ghats, the plain land stations, the coastal stations. So all these things form one particular methodology. So what, as a meteorologist, what we are trying to do is understand what are we doing and why are we doing. First of all, you should know what are you doing and why are you doing. And after understanding this, then you go to the core subjects. What is the physics behind it? And when the physics you understand, then you understand the circulation. And when you understand the circulation, then you can predict, or you can understand what's going to happen tomorrow and whether, and what is the accuracy of your prediction. So for that, the base, like if you have to become an engineer, you have to come from your first standard to 10th standard, and 10th standard, you have to write your exam, you have to qualify, you have to get into an engineering college, and then you do your engineering. You don't directly get into an engineering college, right? So similarly, this is the ABCD of the entire meteorological department, and that's the observation. And unless you don't understand what's observation, you can never understand how to analyze it and how to decode it and how to predict the future. Okay, so accurate prediction of the future is the responsibility of the department, so that you save the economy, you save the people, you save the crops, and you save the animal husbandry. So you try to save things. So you are one of the saviors. So please take your job very seriously and take that pride of being a meteorologist. So it is not a job, something like, we are not doing some kachra work. Okay, so there was a kind of time when my seniors used to tell me, ye kya hai? If you know 1 to 9, you know meteorology. No, if you know 1 to 9, you don't know meteorology. Meteorology is a specified, very specialized subject where you have to understand your basics, and then that should be there on your tips throughout your service. Otherwise, we do not know what we are doing. We just come to office and we go to office. It's a very unprofessional way. So we should be professionals, and we also should be a little more, what you call as concentrating in our jobs and aspiring for a better future. So what we call them as, no shabd har se main bhul jati hu. So career progression is one part of it, and thoda aggressive way and active manner to understand our subject, and especially when you are undergoing a training, be very sincere in your training. So because this is what makes you a meteorologist in future. Okay, so thank you once again to everybody. Yeah, so we'll meet from tomorrow onwards.
Okay.
Okay. Have a great day, guys.
Thank you, ma'am.
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 Bye, ma'am.
Thank you, man.